Dear student, welcome to class system program, unit number 6, part 2, code optimizer. In the last lecture we have seen basis of your code optimizer. What are the code optimization technique? Specifically machine independent code optimizer technique we have seen. Also we have covered the basic topics like the common sub expression elimination, dead code elimination, copy propagation, constant folding, strength reduction, etc. Now we are going to move forward something newer part, that the basic block and the flow graph. So what is this basic block and the flow graph? If we have converted the larger code and the larger code is converted into the intermediate representation, then we people are getting the source code of the larger sequence of your 3 address code. Then that 3 address code is going to be converted into the basic block. Let me see what is a basic block. Basic blocks are nothing but the sequence of statements that are executed sequentially. It means it is the source code having the number of instructions which are always executed in the sequence, that called as the basic block. These basic blocks do not have any jump statement. That is, when first instruction is executed, then all the instructions of the same block will be executed in the sequence as they appear without you losing the flow of control in that particular block. Like if else, if you look out for the if block is being executed, then only the statement of the if are going to be there. Similarly, switch case, if case 1 is executing, then we are following with that particular case 1. Then now the interesting question is, as we are going to partition the intermediate code into that basic block, then that basic blocks are nothing but the sequence of consecutive 3 address code. Then there are few properties we are going to look out. The flow of control can only enter to the basic block through the first instruction of your block. Means there is no any jump statement, and the control will leave the block without halting or branching, except possibly at the last instruction in the block. Then this whatever the 3 address code we are taking, then we are identifying that which are basic blocks. That basic blocks becomes the node of your flow graph, and edges indicates that how the control is flowing from one block to another. So this is the algorithm. In that algorithm we are giving that input is the sequence of 3 address code, and we are getting the output is a list of basic block for the sequence in which that each instruction is assigned to exactly one basic block. Look, we solve this. So these are the some rules over there. The first rule is that the first 3 address instruction in the intermediate code is the leader. Means before starting building the block, we people are identifying the leader. Leader are nothing but the first statement of that basic block. So which is the first statement? The first statement of the 3 address code itself is the first leader. Any instruction that is the target of conditional statement or unconditional jump, it becomes the leader. The second leader is any instruction which generates your conditional or unconditional jump. And the third one is that any instruction that immediately follows your conditional or unconditional jump is called as a leader. Then each leader, whatever the leaders we are getting, then from first leader to next leader we get that first basic block. Then next leader to next coming leader becomes your second basic block. That we need to search for the header statement, that is the leader statement. The first statement of the program is called as a leader. The statement that are target to any branch is the leader, and the statement that follows any branch statement is the leader. Header statement and the statement following them are forming the basic block. So basic blocks are the important concept in terms of the code generation and the code optimization view. Basic block does not include any header statement of any other basic block. Let me see with one example. If you look out that one statement or the source code is having such a multiple statements like w is equal to 0, x is equal to x plus y is equal to 0, then if, then we are having the if block, else, then we are having the else block, and then final statement. Now we want to look for the basic block. as we have seen that the first statement is called as a leader. That means the first basic block starts with that w is equal to 0 until we will not get that the jumping statement. Means if x is greater than 0, means till this 3-4 statement belongs to your the one basic block. Then this block is nothing but that block 2 is going to be executed when x is greater than z. After that x greater than z, we are having the next header statement. That means y is equal to z. And again here we are getting that the loop is terminating. That's why we are getting the new block. That is w is equal to x plus z. Let me revise it again. In that basic block, we are identifying the header statement or the leader statement. By default, first statement of the program is called as the header. The statement that are target to any branch conditionally or unconditionally is the next header, and the statement that follow any branch statement is called as the header. So here a statement which follows any branch statement, that's why this is the header. This is also one of the header, and then this becomes your the new header statement. Look out here. If we are having the 17 statements, let us start with calculating the header. If you observe this example, then the first statement is the header. Then we are going to look out that the second statement starts with the second header. And if you are observing that the statement 9 is giving us that if j is less than 10, then go to 3, means you are going to third statement. That means that any instruction that is the target of conditional or unconditional jump is the header. Means we are going to start with our next block is the B3 block. It starts with the statement number 3. Also, any instruction that immediately follows the conditional or unconditional jump is also the leader. So due to this, line number 10 goes to next block. So that's why I is equal to 1 becomes the one leader. Then j is equal to 1, it becomes to your next block. Then third block, the next block starts with the statement number 3 to statement number 9. And due to any instruction immediately follows the conditional jump, that is a leader, means our next block starts with line number 10. But if you observed, line number 11 tells us that if I is less than 10, then go to 2. Means nothing but that a statement which is the target of your conditional jump is the one leader. That's why this 1 and 2 becomes the separate block, 1 and 2. Then statement number 3 to 9 belongs to next block. Statement number 10 and 11 belongs to next block. And as the statement immediately after the conditional statement is a leader, that's why next block it starts with I is equal to 1. If you observe that again, the line number 17 tells us that if I is less than 10, then go to 13. Means we are saying the next leader statement is that T5. That means line number 13. So that's why these consecutive the consecutive statements are going to be divided into these basic blocks, and we are getting this block. Now we are going to give the name to this block like block B1, B2, B3, B4, B5 and B6. Then here we are going to say that if go to then line number 3, we are getting this line number 3 and this statement is going to be replaced with go to B3. This statement will be replaced with go to B2. Similarly, this statement belongs to go to B5. Now, once we get the basic blocks, then we want to represent that basic block in terms of your control flow. The basic block in the program, they can be represented by the means of control flow graph. The control flow graph, nothing but which depicts how the program control is being passed among the basic blocks. For example, we can enter into this B1 block. After that B1 is executed, if some condition, then we are going to B2. If that false condition, then we are going to B3. And after B2 and B3, by default, B4 statement will be executed. So this picture represents that how the basic blocks are going to be executed. Let me see the example of the CodeOptimizer with help of these basic blocks and flow graph. As everyone knows that we are having the quicksort algorithm. We are very well known this quicksort algorithm. For this quicksort algorithm, we people are getting this is the 3 address code. Quite interesting. Now we are getting for such a only 3-4 line code, we are getting this 30 line 3 address code. Then we have to apply the code optimization technique. So it is a bit difficult to us. How do we compute that the common sub expression, which are the local common sub expression, which are the global common sub expression. That's why this is going to be converted into the basic block. Let me allow our rules. And the rule is the first statement is called as leader. Second statement is means the target of conditional jumping statement. And the third leader is that a statement which is immediately after loop is the third leader. So you people have to do this exercise, identify this basic block, and we have to build the control flow. Then you also have to apply as many as optimization techniques you can. So my dear student, I expect kindly pause the video and solve this exercise. I hope you have paused the video and you have tried to identify the basic block. Let me solve this example as we have having this total 13 statements. So by the first rule that the first statement is the first leader. That's why I is equal to m minus 1 becomes your the first leader. Then any instruction that is target to the conditional jump. So if you have observed here we are having if t3 is less than v, go to 5. Means that's why target means 5 statement. That's why the fifth statement is your the next leader. That's why the line number 1, 2, 3, 4 belongs to one block, and second block starts with line number 5, 6, 7, 8. And as we know, the statement immediately after the condition is a new leader. That's why the second block is up to 9 and third block it starts with 9. Again we are having if t5 go to 9. That's why the next block or leader is the j is equal to j minus 1. The statement immediately after 12 is a new leader. Okay, that means the next block starts from line number 13. Then we are having this line number 14, 15, 16, 17, 18, 19, and now at the 22 we are having go to 5. Means our next block is still 22, and that go to 5 means that your fifth is that the new leader is going to be started. Then remaining statements will be belongs to your one block. Let me see one by one. So are you getting like this? Due to this first rule, then due to this go to 5, this is the leader. Here again go to 5, this is the leader. Then a statement immediately after the conditional jump, that's why this is the leader. Again a statement immediately after that conditional jump, this is the leader, and we are identifying this basic block. Let me represent this basic block in terms of your flow graph. So that's why from line number 1 we are getting this block B1. Line number 5 onwards we are getting this block B2. We are having block B3. We are having block B4, B5 and B6. And we are showing to that after B1 our control goes to B2. After B2 control goes to B3. After B3 control goes to B4. After B4 control goes to B5. And again here we are having go to 5. That's why we are going to go to this B3. Now we have to apply that the common sub expression elimination technique, as we need to optimize this a complete block. So if you have observed here that T6 is equal to 4 multiplied by I and T7 is equal to 4 multiplied by I, means during this block this is called as the local common sub expression. Means these are the sub expression 4 multiplied by I and 4 multiplied by I are common to this particular block. That's why we are going to remove T7. Now again if you have observed that T10 is equal to 4 multiplied by J, and again here T8 is equal to 4 multiplied by J, no use to compute T10. That's why this T10 will be replaced with T8, and T10 is equal to 4 multiplied by J, it has been removed. Now let me go to the next block. In this block, what you have identified, T11 is equal to 4 multiplied by I and T12 is equal to 4 multiplied by I. Let remove T12 and it is being replaced with T11. Similarly, here in this case, that the T15. And we are getting this modified code. If you have observed that again here that x is equal to T2 means we are having this global common sub expression. Whatever the expressions we have been computed here, that the T6 is 4 multiplied by I and here is T2 4 multiplied by I, or nothing is being changed. So that's why instead of T6 we are writing the T2 and this is called as a global common sub expression, and that is going to be eliminated. So like that fashion, again here that the T9 4 multiplied by I is going to be replaced with that T4. Like that fashion, we have to apply your local common sub expression and elimination. And you have observed now that the block B2 and B3 are having the same thing, means it can be happen the dead code elimination. So we people are removing this unnecessary code. That's why we are removing this code over here. Now we have to go for the strength reduction. Are there any statement which are calculating or taking more time? So that's why they are also going to be removed and we are getting that a final optimized code. And that final optimized code is 19 statements. Whatever we having 30 statements. Let me move for the next topic is the loop optimization. The most programs runs as a loop in the system. So that's why it becomes the necessary to optimize the loop in order to save your CPU cycles. So that there are three different techniques of the loop optimization. Invariant code means we have to identify the code which does not impact on that looping statement, keep outside your loop. Then induction analysis, a variable is called as an induction variable if its value is altered within the loop by a loop invariant values. And the strength reduction means replaces the expensive operator with your cheaper operator. So here the loop optimization techniques like the code motion, induction variables and the strength and reduction. So we have seen that the code motion, if you are going to calculate while I is less than or is equal to limit minus 2, every time why we do calculate limit minus 2, let we calculate only once. That's why we are writing why I is less than t. So this is called as the code motion. Now that loop invariant code, it moves the expressions that are constant while over your every iteration. So if you are getting that a is equal to b plus 1 is always the constant, is it possible that we can move this code outside? That is called as your that code motion. Next one is your induction variable optimization. If you are having that this for loop, now here the values are decreased by 2 every time. So why do we having that 202 every time? So let we take that a new variable t1 is equal to t1 minus 2 and we can again use that the strength reduction. So we have seen this peephole optimization technique like the simple local optimization technique. Also we can look out here throughout the code and we are replacing the sequences which are going known as the shorter ones. So now we are going to look out for the optimizing of your basic blocks. So we have seen that the basic block, we can apply local common sub expression elimination, data code elimination, we can use algebraic identities. So all these are the part we have already covered. Now it can be happen that during your applying these all the techniques and we may get a block is generated which does not have any statement, then we can remove that statement, that is called as delete empty basic block. It can be happen that few basic blocks are containing hardly one statement. Can we go for the fusion of that statement in such a way that we are getting only a one basic block, but we have to take care that there should not be any conditional or unconditional jump. So this is our basic blocks which have been shown for your flow graphs. Now my dear students, here are some exercises to you. I expect you kindly solve the program. Whatever the code has been given to you, you kindly convert into the 3 address code. Then you kindly draw a flow graph and try to identify what kind of loops are going to be generated. If for your information, I just want to show you that this block, so we are getting this intermediate representation, then we are getting some basic blocks, and now we people have to identify the loops, means how from one loop to another loop we are going to be executed. So I hope you have understand the technique, that the basic block and the flow graph. Also we have understand that how to optimize the basic block. So these are some exercises given to you. I'm expecting you can solve these examples and you can optimize the code. So in next lecture we are going to look out that the optimization in backend, means we are using that machine independent code. Thank you, happy learning, and see you in the next lecture.